All right, let's talk about similar triangles. Not the same, but similar. First, let's check out a short video.
Let's talk about AA similarity. AA is angle-angle, and it refers to triangles. And what it says is that with triangles, you only need to know that two of the pairs of angles in two triangles are actually congruent to know that the two triangles are similar. And that's because even though the size of the triangle may be different, if there are two angles which are adjacent, and they must be with the triangle since there's only three angles available, then the third angle can only meet in a specific relation to the other two. This other angle will have to be the same. You can think of that from a number of standpoints. You can realize that no matter what this first angle, say z, is, and no matter what y is, the only possibility once we have those two fixed is the remainder of 180 degrees once those two have been taken away. So if A and B are the same size as Y and Z, then that same remainder is going to be available for angle C as it is for angle X. So no matter what size these triangles are, we know that the triangles have to be exactly the same shape if two of the angles match. The other way to see that is to put one triangle on top of the other. I can sort of drag this one over there. I'm going to get part of that little similarity thing, but oh well. If we move this triangle over to the right, you can see that if I set them on top of each other, here, that angle up there on top and on the lower right is going to be exactly the same. And because those upper and lower angles are exactly the same, the triangle can only continue in that direction towards C in exactly the same way for both triangles. So the top triangle may be, or the bottom triangle may be bigger, but it's only because it continues on exactly the same angle. So that lower angle is going to be the same if the other two are. And that means that if we can prove that two triangles have the same two angles out of three, that we know the two triangles then are similar. And if the triangles are similar, it means that their sides are in proportion. And that means if we know any of the sides of one of the triangles and a corresponding side of the other one, then we know everything about the comparison. If, for instance, we know that AC is 5 and XY is 10, then we know that everything about this triangle here is twice as big as it is on this triangle here. All right, let's take a look at how this works with the example questions.
Well, thank you very much there, unknown media guy. So let's continue on. So angle-angle similarity, or what we just call AA similarity, is if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if angle A is congruent to angle F and angle B is congruent to angle G, then triangle ABC is similar to triangle FGH. We don't have to know anything about any of the side measurements. We know automatically, because of the way triangles are designed, that those two triangles are similar. So let's insert some awesome angle-angle triangle similarity example problems here. So are these two triangles similar? State the reasons for your answer. If the triangles are similar, make a similarity statement. Well, we can look here and we can see that two of these angles are indeed congruent, right? We have the two congruent right angles. So we have this angle here and this angle here. Now, angle B is 44 degrees and angle F is 47 degrees. Now, with these two angles here, they have to add up, the remaining angles have to add up to 90 degrees. So 44 and 46 degrees would be this one, and 47 and 43 degrees. So because we do not have two triangles that are similar, the answer is a big, fat no. Okay, now are these two triangles similar? State the reason for our answers, and if the triangles are similar, make a similarity statement. Okay, so here we go again. We do have something interesting here. We have two parallel lines. And because lines are parallel, what we would have here is we've got two sets of transversals going on. We've got one transversal right here, and we've got another transversal right here. So, due to the transversal of segment JL, we know that angle J, nope, I don't like that. So let's just do this. Oops. And let's go with this, and let's go with this. So we know that this angle here is congruent to this angle here. So angle J would be congruent to angle LPQ because they're corresponding angles. They're both on the same position on with the transversal, right? I would say those are both lower right. On the next transversal, this one here, we would know these two angles are also corresponding because those would be upper left. So we have corresponding angles that are congruent. Therefore, the two triangles are similar. So let's make our similarity statement. So we would say that triangle LJK is similar to triangle LPQ. Okay, so side similarity theorem states that if the corresponding sides of two triangles are proportional, then the triangles are similar. So you'll notice these are in red. If JK is over MP is equal to KL over PQ in blue, which is equal to LJ over QM, we would have two similar triangles. Triangle JKL would be similar to triangle MPQ. When do we have to use this? We have to use this when we don't have any information at all about any angles. So, okay. So, side angle side similarity theorem states that if the lengths of two sides of one triangle are proportionate to the lengths of two corresponding sides of another triangle, and the included angles are congruent. Remember, this is the included angle, this is the included angle here. They're in between the two sides that are in proportion that we know the measurements. Then the triangles are similar. So if segment RS over segment XY is congruent to segment ST over segment YZ, then and angle S is congruent to angle Y, then triangle RST is similar to triangle XYZ. Okay, so when do we use this? Well, we only have one angle. So if we have exactly one angle measurement, we would then go to look to use side angle side similarity theorem. So let's insert some awesome side, and side angle side triangle similarity example problems here. Okay, so are these two triangles similar? Justify your answer. If the triangles are similar, make a similarity statement. So let's take a look at the first one here. Well, we can do is we're going to say that we know that these two angles here are congruent because they're vertical angles. So now what we would go with is that we have to see if 8 over 20 is equal to 5 over 12.5. Okay, and what we do is we put a little question mark over that. So we don't know if they're equal. Well, one way we can check this out is just to cross multiply. If we cross multiply, we'll be, and if we're equal, then the two proportions, then we have a proportion. So 5 times 20 is 100. And 8 times 12.5 is 100, and so 100 equals 100. So we are in proportion here. So yes, indeed, we are similar. So triangle PRQ is similar, to triangle SRT. And that would be by side angle side similarity. Now, let's take a look at the next triangles. Well, angle A is our angle. It's common to both triangles, right? We have a triangle that we have right here in triangle AEF. You know what? I don't like how that looks, so I'm going to get rid of that. And let's go with a highlighter. So we have this triangle here, and we have the big one right here. This big one. Okay. So both angle A is in both of those triangles. That's our common angle. So we're going to use side angle side. Now, here's a little piece of information that you don't want to miss. This segment here, oops, I didn't want to use the highlighter with that. I wanted to use the pen. But this angle here, or this segment here is going to be a length of 12. We have to add 8 and 4. Over here, we want to know this whole length here, and that's going to be 15. So, is 8 over 12 equal to 10 over 15? Well, we can do is reduce both of these. Now this is another methodology. So this would reduce to 8 over 12 is equal to 2/3 reduced. And 10 over 15 is equal to 2/3 reduced. So that's another way we can do that. Okay, problem. So that is equal. So we have our similarity. So triangle AEF is similar to triangle ACB. Okay, this one here becomes a little more involved because it is going to be where we have to set up all three of these. Now, here's a little thing that I do when I have to do these. I label these. Here's small, middle, large, small, middle, large. And the reason I do that is so that I make sure that I'm matching things up properly. So, small over small, right? So 6 over 8, is that going to be equal to, the middle is 9 over 12, is that equal to 12 over 16? Well, here's something we can take a look at. This is 3/4, and that's going to be 3/4. And this is 3/4. Therefore, by side, 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 triangle KLJ is similar to triangle PMQ. All right, let's look at the next problem on the slide. We can see again we have vertical angles, right? So we know that, so we're going to be using side angle side similarity here. And we're going to want to put TW over YW. So 10 over 20, is that equal to 11 over 22? Well, no kidding, guys. That's both of them are 1/2. Very good. You notice that. So we do have a similarity here. So we're going to go with triangle TWZ is similar to triangle. Since T went from across this segment here, right, with the 10, I want to go across this one with the 20. So YWF x. Okay, it's got to match up. This is something here, please pay attention to that. When you are doing your problems, you want to make sure that things match up appropriately, right? All right, so now we have a problem where we're going to say, okay, what's the measurements? How do we solve for this? Okay, well, what we're going to do is we're going to have to do a little thinking, a little algebra with this, set it up. So I know that the length of this is 9 3/5. Okay, so 6 over 9 3/5, okay, which is 48/5, right? So 6 over 48/5 is going to equal 5 over, now we've got to figure out this entire length. Well, that's entire length is going to be x plus 5. So we're going to put this as x plus 5 here. So now we just cross multiply, right? And if it helps to write it out, 6 times x plus 5 equals 48/5 times 5. Well, the 5's cancel, so this becomes 6x plus 30 equals 48. Subtract 30 from each side. I'm going to work this way now. And I get 6x equals 18, so x equals 3. So the length of QP, so QP equals 3. And MP would equal 8. All right, next problems. Okay, again, these are, so we know that we're going to go with, now here's a little something you may want to look at is those two, right? So we know that because of vertical angles being congruent, that x plus 6 is going to match up to 2x plus 6, and 8 is going to match up with 10. Okay, so an 8 over 10 is 4 over 5. So I like to reduce whenever possible. So 4 over 5 is going to be equal to x plus 6 over 2x plus 6. So now let's cross multiply. And I got 5x plus 30 equals 8x plus 24. I'm going to subtract 5x from each side. I got 30 is equal to 3x plus 24. Subtract 24 from each side. I've got 6 equals 3x, therefore x equals 2. So we want to find WR and RT. Well, WR is going to be 2 plus 6, which is 8. And RT is going to be 2 times 2, which is 4 plus 6, which is 10. So we actually have a couple of isosceles triangles going on over here. Okay, so some properties of similarity. There is a reflexive property of similarity. You are similar to yourself. So triangle ABC is similar to triangle ABC. We also have the symmetric property of similarity. If triangle ABC is similar to triangle DEF, then triangle DEF is similar to triangle ABC. And we also have a transitive property of similarity. So if triangle ABC is similar to triangle DEF and triangle DEF is similar to triangle XYZ, then triangle ABC is similar to triangle XYZ.
That's all, folks.
These videos are so awesome.